Okay, guys. So today, sorry these are a little bit behind, but I wanted to go ahead and talk about speciation because remember that when you're looking at these slides that I've hyperlinked here, it just shows that speciation is the process by which new species or populations of living things develop from pre-existing forms through successive generations. That's the real definition of evolution. But what does that really come down to, and how's it happen? So what we're basically saying is we're going from, that whale that we all know about to some new form of a whale that cannot interbreed within itself. Let's just look at a few of these examples here. So speciation is a lineage splitting event that produces two or more separate species from a single common ancestor. So when I'm looking here at this, what does it mean when I say speciation event? And I hope that that's what we can go into. But these are all different types of flies that have had different events occurring in their lives to cause them to become different types of species. Now, one of the points of emphasis is that this occurs at the level of populations. As I gave an example in class, it's not just that a giraffe sticks its neck out longer and then all of a sudden evolves, right? It just means that populations of one species over time can evolve to become different species. So that's what I would write in this box here, just that populations of one species can evolve to become populations of another species. Gotta love my handwriting here, right? I'm working on it. So, let me finish that here. Populations of another species. Okay. There's really a two-step process that has to take place, and we're going to talk about those two steps in a few different forms. First of all, populations can become reproductively isolated from each other. So, I'm going to go here to reproductive isolation. So that just means that there are mechanisms, behaviors, and physiological processes that members of two different populations, so emphasize this point here, two different populations, from producing offspring, or which ensure that any offspring that they may be produced are sterile. So what's an example of that? It's like geographic isolation, right? So in here, the description of it is that two populations suddenly become separated by some geographic barrier, whether that be like a mountain, maybe a river, whatever. And then you can draw my sketch here. Right? I like you guys to have visuals, but your populations of beetles could be here. I prefer you to use different colors than I am. But eventually, because they're geographically isolated, this population here is only able to breed within itself. And because of things like mutations and different combinations of traits, and then also different environmental factors that are selective pressures, you're going to get a new genetic frequency in this new population. So successively down the line, because of this new geographic barrier, they become different than this population. Let's go ahead and make these guys different now because they've been isolated, and these guys were only able to reproduce with themselves. And again, because of this barrier, over lots and lots of generations. This doesn't happen in just one generation, but over many, many generations, you're going to see some differences. If we look at temporal isolation here, in the slides, I've given you an example, a few pictures. You get these land bridges that are formed that separate two different kinds of communities. And that resulted in a specific type of fish, the Panamic porkfish, and the original porkfish. once that land bridge was formed about 3.5 million years ago, these were now reproductively isolated and they couldn't reproduce anymore, causing them to, over time, change to fit their specific environments. Same thing with these squirrels here. Even though these guys might look exactly the same, they are actually reproductively isolated as a result of the Grand Canyon. So they are genetically different, and cannot interbreed. Same kind of thing here. Northern spotted owl, Mexican spotted owl. There is a mountain range that we like to call the Rocky Mountains, or the Rocky Mountain Range, that separates these guys from being able to reproduce, even though they're both owls. Example number 2, temporal isolation. This is when populations reproduce at different times. So the example I've given here is American toads mate in early summer, whereas Fowler's toads mate in late summer. So they don't interbreed. And as a result, for whatever reason, the American toad, it was beneficial during their evolutionary process to reproduce in the summer, whereas the Fowler toad, or in the early summer, whereas the Fowler toad was better off reproducing in the later summer. Same goes for these crickets. They've got, I believe it's fall and spring reproductive patterns. The eastern spotted skunk breeds in the late winter, while the western spotted skunk breeds in the fall, so they're not going to reproduce. What that really means for us is that they are getting different gene pools to form. So these are obviously going to continue reproducing with eastern spotted skunks and continue accumulating mutations within the eastern spotted skunk, whereas the western spotted skunk is going to continue accumulating mutations and genetic variations and whatever that might look like in their population by temporal isolation. So if we look back here at our notes, description is that they breed at different times. Let's do it. So maybe you'll draw something like a cute little, oh gosh, cute little squirrel or skunk or whatever here. And maybe you draw that it is breeding. Make sure we give it some legs. Smile. It's breeding during the winter. So maybe I'm going to draw an example of a snowflake. Whereas this spotted squirrel or skunk, whatever it is that I decided to draw as an animal, it can't interbreed because it breeds during the fall. I'll just draw like a little fall leaf here. Hey, that actually kind of looks like a leaf. So no interbreeding. You choose how you put your own drawing on it. But then behavioral isolation. If we look here, behavioral isolation is like basically you've seen the like birds of paradise and how they do their crazy reproductive dancing or like dances to try and attract their mate. I've actually put a video link here for you to access. I'm not going to play it now, but I recommend that you go and watch this video because it's really quite entertaining. But they do a really specific dance that has attracted mates over the generations to specifically select their own, so that the females have a specific kind of dance that they're looking at. And it's really, it's a beautiful process. But they're a good example of behavioral isolation. They develop their own elaborate mating ritual, which eventually can reproductively isolate them from other populations, thus promoting speciation. again, a couple of little video links that I have here for you to go and watch on your own time, just to see that. This is why in class the other day I joked about how at any point in time a woman has likely chosen the traits that are expressed, because it's the woman that has the real power over sexual selection, which is a form of behavioral isolation. And so we can see that with the western meadowlark and eastern meadowlark, etc. So I'm going to add that to our chart here. So behavioral isolation can be described using terms such as mate selection through things like elaborate displays. There are other birds that do things like build nests, build really, really elaborate nests, and so forth. So for me, I'm just going to draw like, I don't know. I'm an awful artist, so something here where you're going to say something about like two animals falling in love based on some ritual. Sorry, guys, just not going to do it. Okay, the next step in speciation is that isolated populations evolve independently. So all those things that I was talking about in step one, behavioral isolation, temporal isolation, and geographic isolation, are forms of them becoming isolated. And so we have over many, many, many generations. Here's my example of geographic isolation. They're going to accumulate mutations as well as undergo selective pressures, and then that's going to cause them to become a different type of species as a result of, in this example that I've shown, the selective pressure on this one was temperature, so it caused these organisms, whatever they are, to become hairy, whereas these organisms here were selected by predation, and so ones with antennae were not favorable. If after time the land barrier or the geographic isolating point is removed, then they cannot interbreed. They are now two different species. Second, look through, these are different ways for species to form. You have mechanisms of speciation, which are in the notes here. So you have allopatric and you have sympatric. So allopatric is a population forms a new species while geographically isolated from its parent population. You have sympatric, where a small population becomes a new species in the midst of a parent population. So allopatric, you've got the geographical barrier. So you can draw your version of that here. So geographical barrier, and as a result, your fish are going to become speciated, different. Whereas in sympatric, even though there's no geographic isolation, they can become reproductively isolated. And that's oftentimes, let's look, I've got a few examples here. So here's some examples of allopatric, which I've noted here as the more common version of it. So all of the different types of fish that form in different lakes in Africa, the land bridge, as I mentioned before. And please take your time, go through these notes and look at them yourselves, but you've got the geographic isolation, and yeah, go ahead and take a moment and look at page 460 and 461 as well to be able to add to a little bit of these sympatric speciation pages. But just take note that this is a pretty uncommon one, but it's usually as a result of temporal or behavioral isolation. Okay, guys, I'll see you back here for polyploidy notes.